Is that showing correctly for you all?
Not yet. Maybe we should switch screen on our end.
Says I'm screen sharing, but it could be lying.
Is our Zoom screen here?
I see it well. It looks nice.
Oh, good, thanks. Pascal sees it. It's a talk for Pascal. It's just between the two of us.
There we go.
Oh, there we go. Fantastic. Thank you so much. All right, great. This was such a fun talk to think about. Hiro asked me to just broaden our minds and think about what are the really biggest questions of solar system exploration that are unsolved. And so I thought of my own favorite big questions, big science questions. What are the unsolved science questions? I thought of my own favorite ones. And then I also did a bunch of crowdsourcing, which was also fun. And so I'm going to talk about three questions, three unsolved questions. And for each question, I'm going to start out with what are we looking for in this question? And then what might we actually measure for this question? And then how would we do it? So some notional robotic parts. And I need to give you all this caveat right up front, which is probably every different point that I'm going to make here is arguable by somebody. And I do not mean to imply that I'm an expert on these questions. So I certainly don't know all the measurements that are needed. I certainly don't at all have the imagination to imagine all the ways to do it. So think of this as a sort of a thought exercise for jumping off. For new missions and new instrument design, think of this as a starting point as opposed to a series of rigorous answers. All right, so the first question is, are we alone? Of course, that's our top question, are we alone? And so this is the what are we looking for part. I spent a lot of time on Discard and Midjourney making images that I thought were suitable for this talk, which was also very, very fun. So this image on the right is meant to imply waves, radio waves, electromagnetic spectrum emissions from a inhabited planet. So this is kind of the ultimate goal would be to find a technologically advanced civilization. But I think that we all understand at this point that the most likely kind of thing that we're going to be looking for would be microbes living under a solid surface of a planet, whether that surface is rock or whether it's ice. And that makes detection so much harder, so much harder. So what might we measure? For microorganisms, we might be looking for something about molecules, the complexity of molecules, the composition of molecules. Could we find something like DNA or RNA? When we're measuring atoms, we look for isotopic fractionation because life fractionates isotopes. We look for evidence of chemical processes, microscopic structures, disequilibrium processes. Is there something that is life catalyzing processes so that they occur faster or out of equilibrium? And then wouldn't it be amazing to look to incubate, to look for long-term observations? Of course, if it's intelligent life, we're looking for signals and structures, but really we're looking for microorganisms. That's the most likely thing that we might be able to find. And so the next question might be, how might we do it? And I loved this little clip so much. I wish that our life observing robots were going to look like that because it's so great. But really, we'd be looking at something more like this. We'd be looking for more rovers the way that we are already. In the background there on the surface, it's a drill rig. We really have got to be able to drill to get down to the likely location of these microorganisms beneath the surface. And having somehow a series of robotic drill rigs would be spectacular. And then, of course, up in the sky, satellites that might fly through plumes and other things that we've already been looking at. And so it seems to me that the search for life, the question, are we alone, the unsolved question, really requires an army of different approaches. And of course, the answer to this question is never going to be no. It's always going to be maybe until it's yes. So every different approach is a welcome one. All right, the second question I want to talk about is how do space weather and planetary atmospheres interact? What might we be looking for? This image is to help you think about the fact that for a very long time, most of us were taught that the magnetic fields of planets with dynamos, that the magnetic field protected the atmosphere from being stripped. We can see on the left the atmosphere is being stripped because that is increasingly coming under argument. Can the atmosphere be stripped? In fact, in some cases, does the magnetic field help the atmosphere be stripped? And then you think about things like the big magnetic storms that we had last year, where even hundreds of air flights had to be diverted, and the structure of our atmosphere was changed temporarily. And so there's so much to learn there. There's so little that we understand, even about the Earth, let alone other bodies with other kinds of atmospheres or magnetic fields and other relationships with their sun. So what might we measure? We might look for loss of atoms and molecules from solar wind stripping, also gain of molecules or particles from solar wind. Looking for dynamics in the magnetic field, in the exosphere and in the atmosphere caused by space weather changes. We need to learn how magnetic storms begin and then how they release electric currents into the atmosphere. That's not known. I was recently told by someone right in this field that it's still not known, even for the Earth, the net flux of energy in from the sun versus out from the Earth. And so even though our atmosphere is so thin and other atmospheres are so much thicker, we still don't understand the dynamics even in our atmosphere, let alone those of other planets, and what the solar wind and other kinds of space weather can do. There are a lot of really fundamental discoveries to be made here. So how would we do it? This is not quite yet the answer of how would we do it, but just an image of the Earth's magnetosphere, the magnetosheath, the solar wind coming in from the left, and bending our magnetosphere around and making a big tail off the back of our planet, and the blue magnetic field lines, and then in the mottled red and purple, the intense Van Allen radiation belts, some of which get right down into the top of the atmosphere, which is barely visible. It's so small in this picture. So just to say that even this simplified picture is very complicated. There's so much more to learn. And why? Why do we care so much about space weather and planetary atmospheres? Because it impinges upon so many aspects of habitability, and also whether or not humans could go to different places, how long we would survive, what the radiation environments are, the surfaces of planets, how they get altered. It's a really fundamental suite of questions. And so here's this image that I made with the colors in the sky are meant to show electric currents and magnetic field and storms in the atmosphere and plasma in the exosphere. And so in this planet, in this picture, there's orbiting satellites orbiting around the planet. Of course, we're used to studying that way, but also tall booms that can measure conditions on the surface, like weather stations, and also electric fields and other things that are influenced by space weather and changes in the atmosphere. And having a robotic fleet of booms, of towers that go out into the solar system and find out what's happening on other planets, I think would be amazing. I would love to see that. All right, third and final question. What is beyond Pluto? I put this in mostly because it's a huge interest of my own. I have not worked in this field, but I think it is absolutely fascinating trying to characterize the population of objects in our solar system that are far beyond Pluto. So here's a picture of Uranus, Neptune, and Pluto's inclined orbit and the Kuiper belt. But what we're really looking for is this. So this is a picture, an imagining, it's an artist's interpretation of the Oort cloud. The big circular spherical, presumably spherical population of icy objects that are the origin of our long period comets. And if you look into the middle of this picture, you can see our solar system in the middle, and this yellow scale bar, which is not a linear scale. So you can see that the Kuiper belt goes out to about 50 AU, and then we're kind of in unknown territory. The outer part of the Oort cloud might be at 150,000 AU, but we don't really know. Only a few objects outside of the outer edge of the Kuiper belt have been seen, and the Voyagers are not yet at 150 million kilometers. So even the Voyagers are not at the end. But there's so much unknown space out there, which is still tied to our sun and tied to the origin of our planets, and that we get visitors in from it occasionally, these long period comets. So interesting. Are there more big planet-sized objects out there? That possibility still exists. So what would you be trying to measure? Of course, the sizes, composition, and orbits of objects beyond the Kuiper Belt, and then a lot of our favorite topic right now, rogue planets and other objects that are not bound to our sun. If we could get outside the Oort cloud, this is really, really, really hard stuff to do. And of course, the farther out you go, the farther spaced objects are. And so just a single spacecraft would never do it. And so I imagined this fleet of tiny satellites, tiny CubeSats with light sails, all going out to investigate those icy bodies out beyond the Kuiper Belt, and many, many spacecraft going out to look. So I hope that these have formed maybe some inspirations for why we would do it, the kind of questions that remain unanswered. And all of us in this field understand that there are so many more questions than they are answers. And I wanted to share with you as a final thought, a few of the also ran questions that I decided not to highlight, but that came in strong from myself or from the crowdsourcing that I did. How is a habitable planet built? So many questions there we still don't understand. How could we humans survive long-term away from the Earth? There's a huge amount of science and exploration discovery to be done by robots to begin to understand conditions. What makes up the fabric of interstellar space? That's going way out. What conditions are necessary for life to arise, and how fast does it arise once those conditions are met? So looking for habitable areas, and niches for life as we understand it in other planets is key. And do all solar systems have habitable planets? Another incredibly key question. So happy exploring to you all. And Hiro, thank you for inviting me to think big.
Thank you so much, Lindy. Lindy, are you okay to stay for a few minutes for questions, if there's any?
Yeah, if I don't know if this is the kind of talk that engenders a lot of questions, because it's really just a thought experiment, but I'm happy to answer questions if there are some.
Awesome. So since Lindy cannot stay for the panel, if there's any questions for her, please raise your hand. That's one. There's the microphone.
Hi, thank you so much for your presentation. Can you hear me all right?
Perhaps you want to come to the
So,
front and speak
I
to
cannot hear that, but maybe you can repeat it for me.
Hi, thank you so much for your talk today. Just wanted to ask, I think have talked with a lot of different astrobiologists for some research that we're doing within NASA Ames. And I think there's a lot of the kind of perspective of rather than saying, is there life beyond our soul or current kind of Earth and just beyond that, a lot of the kind of perspectives is can we show that, I guess whether or not it's specific scientific measurements from different science instruments / different things, can we just tease out the abiotic versus the biotic signatures that we might find these types of measurements? And I would love to hear your thoughts on this, because this is something, at least as an engineer, I'm not a biologist at all, but I think it's a very interesting kind of question to kind of tease out. So I would love to hear your thoughts.
I agree totally with that. It would be so wonderful to be able to really, for sure, know abiotic from biotic. And you see these fights going on in atmospheric measurements of exoplanets all the time. Somebody finds something that they think is the biotic signature, and then people can find 15 caveats. And so one thing that I think is a really great practice, and we've been doing it on Psyche mission recently, is to have people stand up and say, this is how I would interpret this data, or this is what I expect to see from this experiment, and then have other people add caveats. But could it mean this? Or what about the possibility that this could happen a different way? And so those kinds of interrogations in astrobiology have almost always led to the conclusion that most everything we see that can be created biologically can also be created abiologically. And so the question is, what constellation of measurements could we say that together we would be really certain it was biological? I like that approach. And so the idea of looking at molecule complexity and isotopic fractionation, and habitat conditions, some suite of different things. So that's a direction to think for that.
Thank you very much. Any other questions from the audience? Gentleman over there.
Hi, I'm just kind of curious with Are you worried at all that with the potential discovery of other life forms, we could discover something that doesn't fit our current definition of life and we pass over it or miss it completely?
I thought you were just going to stop at our current definition of life, and my answer was going to be, I really hope so. But I don't want us to miss it as a result. This is, I mean, foundational to the whole issue of astrobiology is how do we train even our most inquisitive minds to think of life that is not the life that we know? Sci-fi writers do it better in some ways than scientists do. But we do have some big thinkers out there looking for broader definitions of life having to do with replication and and how energy is taken in and complexity of molecules. In the end, I think it can be distilled down to the question of what is your definition of life, and there are a bunch of them out there. And they can give you guidelines on how perhaps not to miss something that actually is alive. Yeah, and I would say that's not to say that we're not going to miss it or that we don't have a million miles to go in our imagination of how to do this. But keeping pressing on it, I think, is really important.
And I'm sure this is a question that we can debate over, like, many hours or many days. So I'll leave it there. I'm glad that audience asked such a big questions.
Yes, thank you. Thank you, Hiro. Thanks, everybody, for listening. And I'll be down there with you in person tomorrow night for Wednesday.
Thank you, Lindy. See
All
you
right.
on Wednesday.
Bye.
Bye.